Welcome to clickmyproject.com. Let's discuss the project about an efficient multi-object detection and tracking framework for automatic counting and video surveillance applications. In this paper, an automatic visually object detection and tracking framework is proposed to reliable introduced video surveillance and counting based application in the consumer electronics environment. It is based on off-the-shelf equipment such as IP, web cameras and PCs and does not need especially installation and configuration requirements. The detection stage is based on a parametric background subtraction technique that detects the moving region in the input video flow. A post-processing stage refines the detection by estimating and fitting a set of ellipses that represents the moving object to the previous set of moving regions. The tracking stage uses a Bayesian model to simulate the object trajectories. For this purpose, a particle filtering technique is used to predict a set of hypotheses that represent the most probable object locations. These hypotheses are verified using a novel likelihood function that evaluates each hypothetical object configuration with a set of available detection without explicit compute their data association. Thus, a considerable saving in computational costs is achieved. In addition, the likelihood function has been designed to account for noisy faults and missing detections. In our work, we have to work with background subtraction, shadow removal, ellipse fitting. Regarding the ellipse fitting, here we are using rectangle to select the object, and then object tracking, and then object tracking adaptation, and then trajectories. This is the flow of our process. First we load our input video, then we are converting it into frames, and each and every frame is go for pre-processing step. In pre-processing, we are just removing the noises from our input frames. Noise is nothing but undecided information that contaminates on image. These noises are removed using some types of filters. Here we are applying Gaussian filter to remove the noises, and then we will apply Gaussian smoothing. Gaussian smoothing to an image is the same as convolving the image with the Gaussian function. This is known as a two-dimensional Weierstrass transformation. Applying a Gaussian smoothing has an effect of reducing the image's high-frequency components. Applying Gaussian smoothing has the effect of reducing the image's high-frequency components. A Gaussian blur is thus a low-pass filter. Then we will go for adaptive GMM. Gaussian mixer model is a probabilistic model for representing the presence of subpopulation within an overall population. Formally, a Gaussian mixer model corresponds to the Gaussian mixer distribution that represents the probability distribution of observation in the overall population. Then we will go for foreground extraction. Morphological operations such as closing and opening are applied on the noisy foreground mask. Connected component analysis is done to find and draw the object contours. Then we will extract the foregrounds. Then we will go for shadow elimination. The identification of shadow is done by comparing all the non-background pixels against the current background components in the YCBCR color space. If the difference in the both chromatic and brightness components are within some threshold, the pixel is considered as shadow. Finally, we will go for our foreground masking, detecting the moving object from the difference between the current frame and the reference frame, often called foreground masking. Foreground masking is a widely used approach for detecting moving objects in videos from static cameras, since some image regions of interest will be in its foreground. Now let us see the execution of the process. First we select main.m file and click run file. This is the MATLAB GUI window designed for geometric based object association and consistent labeling in multi-camera surveillance. We will go for first we will load our input image. These are the data set. First I select video. Video is loading and played in this place. Video is played, and then frame conversion
frames are converted, and next for pre-processing is applied. Here we are applying Gaussian filter to remove the noises for the total frames, and then we will go for our adaptive GMM based foreground pixel extraction. Adaptive GMM can be used to determine whether a new input pixels belongs to the background or the foreground. If the pixel matches one of the B distributions, it is treated as a background, otherwise it is a foreground pixel. Gaussian smoothing operation is applied on each input RGB frames. Through performing frame difference between the smooth input and the background image maintained by the adaptive GMM, the foreground pixels including moving shadows are extracted first, and then we will go for shadow removal. The identification of shadows is done by comparing all the non-background pixels against the current background components in the YCBC or color space. Here we will eliminate the shadows. Then we will go for and then object or extraction process is done. In the object extraction, we first find the draw contours in the filtered foreground masks. Here we find the contours. Then finally we will find the bounding box where the object is moving. Here the bounding box is clearly watched our moving object, even if the size is changed. Thus our algorithm works properly. Thank you.